Hello, welcome to my channel. Today we have Leetcode 224 basic calculator. So giving a string as representing an expression, implement a basic calculator to evaluate it. So now you see example 1 as equal to 1 plus 1 is equal to 2. So basically, this is a basic calculation. We have expression and the number as a string input and output the right number as after the calculation. So now you see I don't have much explanation for this question. So let's jump right straight to the questions. So this question is rated as hard. So actually I break it down, become two medium questions. So first, you have the basic calculation, and we do that first, and later we'll take care of the parentheses as the order of the calculation. So now we take a look at the first part first. So I will make a int cal to calculate the basic calculation without the parentheses. So we also take in a string as that, and we will start as total is equal to 0. Because this one I don't want to take too long, so I will just jump straight to the code, and it will self-explain by itself. Basically, we go into this backward. So now you can see going backward for this string, we capture this one into a temporary string. If we see this plus sign, then we'll add the temporary string to the total. If we see minus sign, we add the temporary string, minus from the total. That's it for this one. And when you loop through the entire string, and you see the last one, and we'll put the last one to the last. So at that time, and at last, we will add this back to the total. That's how it is. So if string equal to null, so now we have in last, we're going from backward, which is 0. So int power, I will tell you why we need to use power later, because we need to rebuild this number from scratch. So now we have I starting from as dot length minus 1, which is the last digit of the string, I plus or equal to 0, I minus minus, going backward. Sorry for the typo. Now we have chart, which is current equal to as dot chart at I. So right now you go through every character. So the current character will be current. So F if that character current equal to space, and then we discontinue and ignore it. So F current equal to plus sign, we do something, else if current equal to minus sign. And then we do something. And the rest will be digit in here, right? We do something in digit. So what if it's digit? So if it's digit, then we accumulate to the last, which is the last number right here. How do we accumulate? It will be last plus equal to current minus 0. So current minus 0, because current right now is character. Character minus 0 will be the integer of the representation of current. So now we have current, for example, is 1 right here, and current math.power 10 power. What does that mean is met the power 10 of power. So is now is currently 0 digit. So in here 0. So we time 0, 10 power of 0, which is 1. So it doesn't have anything. So when we add another one right here, if it's 2 here, power will be at 1, and then power will be 2 at that time. Actually, power will be 1 at that time. So need to have the current digit here times 10. So we'll be building up this integer right here. So people ask me why we don't use the string builder to build this one, since this is character. There's one mistake in here is string builder is using log n as adding a new character in the string builder. So if we have n for loop here, and in here we have another n, the time complexity will be n squared just to this 2 for loop. So eventually we cannot use that one if we have a limitation for that one. So using digit one by one and build up another string, build up another integer, or using only linear time. So this is last. After we build this last, we'll have to increment power by 1. After power by 1, and we also need to, I think that's it for this one, just to build the last integer. Now power is updated. So what if it's add? We need to fill this one. Total add plus last digit. So after that, we need to reset power equal to 0. And also last equal to 0, right? Update it after you add those, add the last to the total. In the same time, if this is the case, right? Okay, last in here, power also reset equal to 0, last equal to 0. Okay. So this is a for loop, it's done. So now, let's see what's missing. Give me a second. So now we, for example, in this example, this is last and this is plus. So we have to put this last integer into the total, and we'll keep looping to the end. And now we update this to the last. At the end, we need to add the last to the total. So now we have this total updated. At the end, return total. As a result, and we can test this on original calculation. So we will return cal, see if it's passing the case. So now in this case, it passed. So ignore the space in here, 1 plus 1 equal to 2. Cool. So the individual one looks good. Can also test this case. See if it's working. Cool, it's also working too. Everything looks good without the parentheses. So now we have a helper function called cal, and we assume that it's working now. But when it turns to example 3, it won't work because we have additional thing to consider, which is the parentheses. In this case, as we did a lot of stack question before, the first thing I would think of is using a stack. So now we can look through the whole entire string up until here. So we always have the left opening. But when we see the right opening, what we can do is start looking everything until you meet the left parentheses. So what is this? So this is what we can do with the helper function, right? So we can put this string into the helper function and we come up with 11 right here and put that 11 back to the stack. As what we know is in the stack we have, now it's the stack right here, 1 plus 4 plus 5 plus 2. So when we see this right parenthesis, we take all this into that calc function. We get 11 right here. Now we can replace this one, become 11. Put this 11 back to the stack. We take out this one for sure. So now we have 1 plus 11. And we have minus 3. And now we have another parenthesis. Then we put this one into the calc function again. Then we have minus 8, it will be 9. And take out everything. So the stack we have 9 right now. What left? And plus another parenthesis, 6 and 8. And now we close it. So we just keep doing it. And then we have this 6, 14, back to here, 9 plus 14, and we come 23. And then we clean this stack right here, and it'll come up 23. So that's the solution for this, another function. So now we code this out. Now we have the calc function we can call anytime. So first we have a stack. So also check if str is equal to null. That's the case, return 0. So now we have int. Sorry, I'll clean this up. We have in total again, it started with 0. As we mentioned, we will have loop through the character in the string dot to chart array. Now we loop through the entire string. So f c equal to, as we know, if it's empty space, then we continue. Cool. So f c is not equal to right brightnesses, right? Then what we can do is stack, put it in the stack. So everything, so we already take care of the space. So if anything's not right parenthesis, we put it to the stack. Else. So this else, that means C will be equal to the right parenthesis. So this is the long thing we need to do. First, we have a string called current to keep track of, in this case, which is 452. So this is the first parenthesis we need from right side. And we will capture everything until the left parenthesis, the first left parenthesis, equal to empty string. We have to have a while loop. That while stack is not empty. And stack peak is not equal to the left bracket, left parenthesis, right? So at that time, current is equal to stack dot pop this out plus current. We add it to the front. That's what it means. So after we add all this to the current, so current will be this operation here. Next thing we need to do, pop this out, pop the left side out. So we have stack dot pop out the left parenthesis. We'll have int, and we call this recursion function current int equal to cal cur. So what's cur? Cur is this one. We put this to the function right here, and we calculate the integer for this current int right here. Now we need to put that back to the stack. So if this is really important, stack is not empty, and stack dot peak not minus. So I will explain right after this code. So what that mean is, if there's a case right here, so for example, the thing in here is a negative number, and here is a negative sign. So we cannot have negative one. They don't know what's negative. So that means if the peak of the stack is a negative, and this current int is less than 0, then we'll take this out, and add the plus sign there. Stack dot pop. Ouch. So after pop this one, stack will push back a different sign there. So now what we can do is invert this one, this number, right? So current int equal to negative current int. Invert the sign, and that should be it to cover this kind of cases. And now, for example, in this case right here, I change it, I got it. This case right here, we have this string and calculate the total is 11. We need to add the 11 back to the stack. So we have a string, current string equal to current int plus this. So basically put the int to become a string. So now current int is 11, and now it will be 11 like this in a string form. We loop through this string and add that back to the stack. Add every character back to the stack. Cool. And stack.push string.character.I. So now we put that back to the stack again. And let me double check, okay. We'll have all this for the for loop. So now we look something like this in the stack. even though this is calculated already. So the current stack will look like 23 because they already calculate this one and put it to the calc function. What we can do is pop that back. Okay, put this back to the total. In here, we haven't added anything to the total yet. We'll have string last equal to empty, like what we did last time. So while we know the stack is not empty, and I just make a one-liner right here. So why the stack is not empty, last equal to stack dot pop plus last. So what that mean is just put this back into 23. So now stacks right here is 3, become 3, and then when we take 2 in here, we put it to the front of that last. So last will become 23 now. Then total equal plus cal last. And then we'll have, after this, total will capture everything. Yeah, at that case, and return total. Just double check if any edge cases came out. So now hopefully that works. It looks good so far. So now we just capture this one and try to run this case. Cool. I think it will ship pass. Cool, and it passed. Let me erase this one. It's cool and pass everything. Hopefully that clear using the example as a stack. And you see, I kind of have a lot of edge cases in here. I just start making this the first time. I think this is a really good question I've been asked with different company, and it's really good to know. So this hard question actually combined two mini questions. And also people use recursion to do that, but actually recursion is a really bad idea as a time complexity wise, and I not recommend it. So you can see if you recurse this part, so one case that will break the recursion will be, we have a lot of this. I just guess maybe like 1,000,000 of them, 1 plus 1. So the recursion will call this recursion. For example, this is 100 of them. So F100 will be equal to F98. So F98 will be equal to F probably 96. And like every time they recall this one, and now they recall another one with one less bracket in there. So this is really bad in time complexity. I mean, the space complexity. So you keep calling a lot of the same space basically. So it's not efficient. So it's not linear. It's getting bigger and bigger. Single size is getting bigger. Yeah, that's why I don't like recursion. Some of the case, but if you want to do that, it's totally fine. So if you have any question or suggestion, please let me know, and I will get back to you as soon as possible. I will see you then. Bye bye.